So let's do an example. So if we have vector x, and that's equal to 2 times vector a plus 4 times vector b minus 3 times vector c, and y is equal to vector a minus vector b plus 2 times vector c, find expressions for both of these in terms of vectors a, b, and c. Now, I wrote out all of the laws that we just went over in the previous videos here on the side, and I'm not going to go over them in detail, so if you haven't watched the videos before, make sure you do. But what I'm going to be doing is I numbered these laws here, and whenever I apply one of the laws, when I am finding an expression for both of these, I'm going to just put the number for the law that I use for each line. So let's start with this expression. So vector x minus vector y. So let's plug in for x this expression in terms of a, b, and c. Same thing for y. So we would have 2a plus 4b minus 3c minus vector y. A minus b plus 2c. Now the first thing we're going to do is notice how there's like a -1 in front of this bracket. So that's a scalar. So what I'm going to do is I'm going to distribute this scalar inside the bracket. And if you notice, that is the distributive property of vector addition. So for the next line, I'm using law number 3. So this I'll rewrite as is. And then I'm just going to take this -1 and distribute it in the bracket. So the -1 would go in front of each separate vector. So we would have -1, vector A, -1, and this is negative vector B, and then -1, and this is 2 vector C. Alright, so I just took this -1 and I put it in front of each vector using the distributive property of vector addition. Now, the next thing I'm going to do is I'm going to take each of these values here and I'm going to multiply the scalars. So I'm using the associative law of scalars, this law number 4. So 2a plus 4b minus 3c, -1 times vector a is just -1 vector a. -1, there's like a -1 in front of this b. -1 times -1 is positive b. And then -1 times 2 is just -2 vector c. So here I used law number 4. You know what? Maybe I'll put these in red so we can differentiate. So this was law 3 that we used, and this is law 4 that we used. Now what I'm going to do is I'm going to rearrange this so all the vector A's are together, all the vector B's are together, and all the vector C's are together. So I would be using the commutative property. So let's start with the A. So I got vector 2a, and then I got this -1a, plus vector 4b plus this 1b here, minus 3c minus 2c. So all I did was I took this and I rearranged it. So I used law number 1 for this line. Now what I can do is I can factor out the vector from each expression. So that would be the distributive property for scalars. So if you notice, if I take out vector A from these two, I would be left with 2 minus 1 in the brackets. Plus, if I took out vector B for these, I would be left with 4 plus 1. And then if I took out vector C for this one, I would be left with -3 minus 2 in the brackets. Alright, so I just factored out the respective vectors from the expressions, and I'm left with scalars in brackets. So we use this distributive scalar property. we kind of went backwards. So we had MA plus NA, and then we factored out an A, and we were left with M plus N. So that's all we did in this line here. So in this line, we used law number 5. And then just adding the scalars in the brackets, 2 minus 1 is just 1, so we could just write that as A. 4 plus 1 is 5B. And then negative 3 minus 2, that just ends up being negative 5C. So that ends up being our final answer. Again, the algebra is very easy. It's almost like polynomials, just distributing and then collecting like terms and then adding or subtracting. However, you have to be able to know which law you're using when you're going to each line. So make sure that you are referring to these laws. Maybe draw these out on the side so you can refer to them better when you're doing these questions. Alright, let's do our second expression here. So we got negative 2 vector x plus 3 times vector y, and we need this in terms of vectors a, b, and c. So same thing. Negative 2, let's sub in vector x here. So vector x is 2a plus 4b minus 3c. Plus 3, and then vector y is vector a minus vector b plus 2 vector c. So now what we're going to do is we're going to take these scalars in front of the brackets and we're going to distribute them inside of these vectors. So we're using the distributive property of vector addition. So property number 3. So I'm just going to take this negative 2 and put it in front of each of these vectors. So we'll have negative 2, 2a, negative 2, 4b, negative 2, negative 3c, and then I'm going to take this 3 and distribute it in front of each of these 3 vectors. So we'll have positive 3 vector a, positive 3 negative b, positive 3, and this is vector 2c. So we're running out of room here a little bit. So from here to here, I just used property 3. Now what I'm going to do, same thing here, is I'm going to take all of these scalars and put them together, multiply them together. So we would use the associative law of scalars here. So we are in this format now where, for example, this vector, this negative 2 is like this m, and this 2 is like this n, and you can multiply them and then just put them both in front of the vector itself. So negative 2 times 2 is negative 4 vector a, negative 2 times 4, negative 8 vector b, plus 6c plus 3a minus 3b plus 6c. So the law that we used from this line to this line was law number 4. And then I'm going to collect like terms, so put all the vector a, b, and c's together. So I'm going to use the commutative property. So I'm going to just rearrange this. So negative 4a plus 3a minus 8b minus 3b plus 6c plus 6c. So I used law number 1 here. Now what I'm going to do is I'm going to use this property 5, this distributive property for scalars, because now it's in this format, MA plus NA, so I'm going to factor out the respective vectors A, B, and C from each of these, and we'll just be left with scalars in brackets. So negative 4 plus 3, I could factor out vector A from these two. From these two I could take out vector B. So in brackets I'd be left with negative 8 minus 3, vector B, and then with these ones I could take out vector C and I'd be left with 6 plus 6, vector C. Negative 4 plus 3, that ends up being, so sorry actually, before we go further, here I use law number 5. And then just simplifying the brackets, negative 4 plus 3 is negative 1, so that's just negative vector A. Negative 8 minus 3 is negative 11, vector B. and then 6 plus 6 is 12 vector C. So that ends up being our final expression for this original expression that we had. Again, it's just like polynomials, distributing, collecting like terms. However, you have to be able to refer to these 5 laws, especially if your teacher is very strict, in order to get full marks on the test.